all of you in person as well today. But Qadarullah bi'isnillah, I have been infected since last Thursday or Friday. I'm not sure when the exact day, but I still have that symptom. So I'm worried if I'm meeting you, it will put you in a much greater risk of being infected with COVID. Okay, so this is the reason, also the reason why I'm not actually carrying out this lecture from my other office, because that office is surrounded by people. So I actually took the initiative to present, to run the lectures from my own office in KICT, which is then I can minimize the interactions with more people, or putting more people in avoiding putting risk on other people. Okay, so let me just try as usual, run the attendance for everyone. Just want to make sure everyone's here. Okay, so today is 17. Okay, just want to make sure everyone's here. Zahim, is Zahim here?
Yes, ma'am, I'm here.
Okay. Abdurrahman?
Yes, madam, I'm here.
Thank you. Sajibur Rahman?
Yes, ma'am.
Sajibur Rahman?
Yes, madam.
Okay. Bari, I see Bari here just now. Yusuf, I saw Yusuf just now. Amira? Sama Amira?
Yes, madam.
Okay, Rukia?
Yes, madam.
Okay. Sheila?
Yes, madam.
Okay, thank you. Asima?
Here, madam.
Okay, thank you. Munir?
I'm here, madam.
Okay, thank you. Sarah? I saw Sarah just now. You're here, right, Sarah?
Yeah, I'm here.
Okay, good. Herda? Herda? No. Okay. I saw Rehanul just now. Aisha, I saw Aisha just now. Saada?
Yes, madam.
Okay, good. Thank you. Farihan?
Present, madam.
Thank you. Farjana? Right, thank you. Shafiq?
Yes, madam.
Okay, good. Hafni?
Yes, I'm here.
Thank you. Mustaqim?
Yes, madam.
Okay, good. And I know Nisa there. Okay, good. All right, so thank you so much, everyone. So today, as planned, we're going to have the regression. So this is among the topics that we're going to have for this semester, which will help you for the group project. I know I'm kind of like delaying the releasing the group data sets, the group project data sets. Initially, I want to give the original data as is. I think I've mentioned it to you last week, but now the more I think, the more I want to make sure that I captured the skills that I have been trying to develop in the class. So I, rather than giving you the data of 6 months with 35 machines, so I'm trying to simplify the project so that it is doable within the remaining weeks that we have. And also, I don't actually expect the projects to be submitted before the final assessment. So I will give you ample time for you to finish the group project, inshallah. But on the same time, I try to simplify the level of difficulty so I can see the actual deliverables, which will be beneficial not only for you, but also for the company. Okay, so what we're going to cover today is the regression techniques, which I'm very sure you have learned this in data mining. I'm not sure how many of you is taking data mining this semester. Anyone taking data mining this semester? Can you respond in the chat if you're taking this data mining this semester? Okay, only one person.
Some people are raising their hands, so.
Oh, okay, all right. Wow. Okay, so it seems you are juggling two similar courses on the same semester, because initially when we designed this course, business data analytics is meant to be taken after you're taking data mining. But I think now, since that there's no more restrictions, I can see a lot of people taking both courses on the same time. All right, which is fine. Hopefully what you're taking in this course will help you to understand the other course, as well as vice versa. What you are taking in the other course will also help you to understand in this course. Okay, so what I want to share with you on the regressions today is basically the concept of how we can actually predict values based on some of the values that we have. I think it's if you have heard the terms classifications, regressions is part of the classifications. The only difference is that in classifications you can have a number of predictions, number of output, number of decisions. I think I should put it that way, number of decisions. But in regressions, we will only get one values as the predictions, which is the values will have to be in the form of numeric, okay, or continuous variable. So let me just, sorry. Okay, so let me go through the concept first. Anybody familiar with the terms of regressions? Have you covered this in data mining? Have you covered the regression topic? Yes?
Not yet.
Not yet? All right. Okay. So if this comes first, then hopefully it will help you to understand the regression topics once you go through it in data mining course. Okay. All right. So is the slide clear?
Yes, ma'am.
Okay, good. Thank you. All right. So this is what we're going to go through today. We're going to have a look on the trend line and regressions analysis. As in many data analytics, you would want to focus basically on looking at what you have in the past data and how it can actually help you to better understand the kind of decisions that you have to make from the data, using what happened in the past. So that's the whole thing of why we are actually doing data analytics in the first place, right? You want to make sure what you have been collecting all these whiles will enable you to make a much better decisions for the future. So in data analytics, there's one of the techniques which is called regressions. The whole rationale is about the same. But in these particular techniques, what we want to focus is that we want to build some kind of relationship. Can we actually see what are the contributions? Say you want to predict what contributes to the profit. Okay, so you want to see, to predict a profit, what are the factors, what are the variables, or some people call it factors, some people call it variables, that actually contribute for bigger profit, or for a larger profit, or for a higher profit. Okay, so you can have a look later on, perhaps does the expenses, does the cost of salary, or the cost of maintenance, or the cost of the raw materials contribute to the profit. But not only you will be able to see, yes, it contribute, but also you will be able to have a look how much contributions, how big it contributes to the variable, to the profit. Some variable is expected to have a negative correlation, which means that the higher the expenses, of course, you have less profit, right? So we call it as a negative correlations. But we will also have a look on the variables that actually contributes to higher profit. So perhaps because of you have you have a higher efficiency, you have to hire less part-times, so you have less expenses. In this case, you will have higher profit. So in this case, we want to have a look. What we want to have a look here is not only we want to see the correlations, but we will also have a look on, okay, so we'll also have a look on how this independent variable actually influence the dependent. So it correlates, but in what way? How much contributions these independent variables, how much contributions these independent variables play on the dependent variable. Okay, anybody still remember what is dependent, what is independent variable? Oops. Anybody still remember what is dependent, independent variable? What is independent variable? Can you give me an example? Anyone?
Period.
Sorry?
Time period.
Time period. What would that be? Is it dependent or independent variable?
Independent at x-axis. Independent will be y-axis.
Okay, so example of independent is time. Is that what you're saying, Safik?
Yes.
Okay. Okay, so say this is time. If this is independent, what would be the dependent variable, do you think?
Like money, salary.
Salary, okay. Okay, so the dependent is salary. How the dependent variable be salary? So how this contribute, how the time contribute to the salary? Means the more you work, the more time you work, the bigger the salary. Is that what you're saying? Shafiq?
I think so. Or maybe the experience.
Okay, all right. So if it's not time, experience, okay. All right. Actually, what you said is correct, but I think every time you put independent, every time you define what would be the independent and dependent variable, you also have to look at the context. Okay, so for example, just now you mentioned that salary will very much depend, how much you earn will very much depend on experience. So why the experience is independent in this case? When you want to say things is independent means that usually why we want to call it as independent is because we have no control over that particular variables. Okay, so for example, the say we are talking about the chances for today to be rain. Okay, so the dependent variable would be rain or no rain. Okay, so the status whether it will be raining or not raining. So that is the dependent variable. What is the independent variable? The independent variable would be, for example, the precipitation. Okay, so how much cloud, how would likely in terms of the temperature, for example, the precipitations, the humidity. So those are the variables that we usually call it as independent. Why is it independent? Usually because we have no control over those variables. We have no control over those factors that will contribute to things to happen. So the same thing like this, when we are talking about independent and dependent variable, usually we want to see how this variable that might change will actually be changed by the factors that we have no control towards making sure things are in the other or happens in different way. But people usually in this time, I mean, with the much advance of data analytics, people wants to see whether things that we can control, for example, salary, will that also have some independent variable which we still able to control? Like for example, experience. You still can have control towards experience, right? Means that if you are trying to get more experience, you can actually control over this variable. But on the same time, we can also have this as independent variable. So in this case, I think now, I'm not sure whether you have heard a lot of, if you have actually play around with a lot of data analytics, there's a lot of things called mediating variable. Okay, so there's notions of mediating variable or moderating variable. Okay, so moderating variable, things that you still have control, but you also want to see how this variable affects other variable. Okay, so I think it's good that you mentioned about experience just now. Experience is, yes, in this case, it could be in the context of whether your salary will be contributed by your experience. Yes, in that case, the salary is in the dependent variable, the experience is independent variable. But on the same time, if you want to analyze whether the salary is actually affected by experience and whether the experience is affected by the numbers of years you have been working in the company, okay, so that the experience on that particular example, because it is in the middle, we call it as mediating variable. It actually things that might change other things to happen. Okay, so this is why we have to be careful with every time you are working with data analytics. You have to be careful. You have to understand what do you want to achieve from the analysis. If you want to analyze the salary, then you have to understand the nature of the salary. Is it independent or is it dependent variable? And what would be the dependent variable? What would be the independent variable if you want to analyze salary? It may not be just experience, could be some other things. Okay. So this is why independent and dependent variable is very important. In the case of regressions, for example, we also want to have a look how things change. But in this case, again, as I've mentioned earlier, instead of looking at many possibilities, we want to look at the values, the exact values of how much we will actually, how much it actually sets in terms of price, for example, sets in terms of profit. So in this case, we are predicting future results in the form of numerical values. Okay, so variable, what would be the variable that might influence the regression? It could be many variables. In the case of home price, for example, it could be the age of the house, it could be the size of the land, it could be the positions of the house, the amenities nearby, the crime rate. There's so many things that actually can contribute to the price of the house. Okay, and in what way can we use the regressions? There are many ways, and among others, regressions has been used extensively as a predictive analytics, which in this case, it can actually give you, again, some kind of hunch of what would be the future opportunities that you might actually get from investment, from taking risks on certain kind of joint venture, for example. So there's many ways people actually use this regressions for. As simple as you can actually use it to sort of predict the price of your house if you would want to see how much the price in your areas would be. Okay, so this is one of the example. A company can forecast the number of shoppers who will pass in front of a particular billboard and use that data to estimate the maximum to bid for an advertisement. As you can see, just have a look on the, just have a look on the highway nearby, right? There's so many billboards. Do you think that every billboards in KL have the same price? Do you think all billboards have the same price in KL? What do you think? Anyone? Does all billboards in
I
KL?
think that
Mhm.
the if there is a traffic in the highway, the billboard will like cost more because people would just be waiting for the traffic to, I mean, to start their car, so they will start looking around and see the advertising more than. So the places where they mostly will have a traffic, they will cost, the billboard will cost more.
Very good, Yusuf. Thank you. Yep. So the price of the billboard, the price of the billboard will actually depend on how heavy the traffic is, how many people actually pass by the billboard, how many cars pass by the billboard. And actually, you might be surprised, but there are people who actually count how many cars pass by, because that's part of the not only part of the urban planning, but also part of the marketing. These people, the marketing people, they really love this kind of informations. Now, especially with the sensors, people can actually see how much cars actually passing by certain busy areas in the cities. And of course, this billboard the price varies from place to places, not only by the size of the billboard, but also the place to places, because in this case, people wants to see, the company would want to put the billboards on the areas that is busy, rather than a huge billboard, but you barely see any cars pass by. Okay, so thank you, Yosef. Yes, that's right. The price of billboards are varies even within KL. Okay. Any questions before I proceed? Is it okay so far?
Yes,
Yes.
Madam.
Okay, good. All right, now let's have a look on the regressions models on operation efficiency. So regressions model can also be used to optimize business processes, such as analysis may improve the business performance by highlighting the areas that have maximum impact on operational efficiency and revenues. If I can give you a hint, I would probably, if I have to analyze some of the data that these companies provide, I would actually looking at how regressions might actually help, because most of the data shared by these companies actually in the form of numbers, numeric, so it's easier for me to analyze. Forecast, if you're comfortable with that, I think would be another technique which you might probably wants to have a look at in analyzing the data for your group project. Okay, so I have given you some hints. Probably can have a look at those techniques later on. Okay. Oops. Right. So some other operation efficiency is, for example, if you're working in call center. So, so in call center, usually we want to analyze the relationship between the wait times of the callers as compared to the number of complaints. This is very common. I think even I've seen last time when I visited Mimos, they're not only doing this for call center, they're even doing this for the immigrations in the airports. So how many how many passport were able to be actually completed by certain staff, and then it's very interesting to see the regressions of how many is predicted during the peak time, during the normal time, during the low season. They even have that to see how many staff, how many manpower should be deployed during peak season and whatnot. So this is one of the operation efficiency that which can actually benefits from using the regressions. Some of the example when it comes to productions, you can actually have a look how the regressions can see can actually be used to predict what will be the optimum temperature to, for example, to set the shelf life of the cookies or for the bakeries in the ovens. Okay, and the business today are overloaded with data. I think we've discussed about this so many times. There's so many data. And what we want to see is that by using all these regression techniques, we can actually make some much better accurate decisions. So not only you go by the hunch, okay, so I think we should set the temperature this hot or this high, and then eventually you risk putting some of the batch of the bakery of the cookies or bakeries because of its too high, the oven is too high, and then you waste some of the raw materials. Okay, so in this case, I think by looking at what would be good based on the data, you can actually make a much more accurate decisions. And okay. So regressions is not only great for lending empirical support, but also identifying errors in the judgment. This is one of the example how we can actually use regressions to see how much or how we can actually minimize the errors. Okay, so this is one of the one of the use cases from real companies. So retail store manager may believe that extending shopping hours will greatly increase sales. But finding from the business is that regression analysis indicate that the increase in revenue is not sufficient to support the rise in operating expenses due to longer working hours. For example, such as the additional employee labor charges and so on. And regressions analysis can provide quantitative support for decision and prevent mistakes due to the manager intuition. So in this case, we logically, we might think, okay, so by having longer hours means we have more income. But we often forget longer hours means that you need additional manpower. If the shop's supposed to close at 5 and then you extend to 7 o'clock, means that the remaining 2 hours from 5 to 7 that will be considered as additional hours of working hours. Usually we call it as overtime, right? And the charge for overtime will not be the same as the normal rate during the day. So in this case, that is additional cost for the retail store to actually incur. So in this case, if you're able to see how this regressed, how this actually mapped into a proper technical analysis, proper and statistical analysis, or proper data analytics analysis, proper data analysis techniques, then you can have a better justification to the company. No, adding longer hours, not necessarily you make more profits because of you still have to have this additional staff man the store, and then you still have to have this cost incurred for the electricity, for all other things, for transportations and whatnot, which again it may not be covered by the amount of transactions that we usually have after office hours, after hours. Okay, so in this case, I think with a much better analysis, you can get a much better feel whether your decisions is correct. Okay, another example. So regressions analysis techniques can find relationship between different variables. Okay, so in this case, we can also have a look on point of sales. For example, whether the demand on certain days or what are the products that actually more likely to boost the profits on certain months. So this is what we call as optimal stock and personnel for the demand and supply. Okay. All right. Now let's get into the technical. I think I've given you ample information in terms of how you can actually make use regressions in technique in the business. But now let's have a look on the techniques itself. Okay, so I'm very sure you have heard about linear regressions. We'll start with the linear regressions first. So this is linear regressions. Okay, so we are predicting the y variable. So linear functions shows a steady increase or decrease over a range of x, and this is the simplest functions. If you do not understand this, then I think you will really have to drill your notes and books again on this, because this is the simplest one on regressions. We are predicting these values. We are predicting the y variable, and the y variable is affected by combinations of, could be more than one of factors that influence this. Okay, so if I can put it in much better descriptions, is like this. Okay, so x is independent variable. So just now we've discussed about independent variables, right? So we might have more than one independent variable. Okay, so we have dependent variable. This is what we want to predict. We can have many independent variables. A is the y-intercept. So usually it will be in the form of absolute values, and epsilon is the random error, which is the difference between the actual values and predicted values. Okay, later on, perhaps once you have a look at the results, you will be able to visualize what all this variable means. Okay. So feel free to have a look on the slides later on. I just try to put some additional information just to give you a feel of what regressions mean. But I think one of the things, if you later on in the result, you have a few items, you have a few results. I want you to focus on these few items for a start. Okay, so I want you to have a look on the R square. So what the R square means, R square is a measure of the fit of the line to the data. So if you have 1, means that the perfect R square, which indicates the perfect fit of all data points. So if you have this kind of graph, okay, if you have a lot of data actually predicted like this, which is a bit far from the line, means your R square will be low. But the more the closer it is to, if you have something like this, all is very close to the line, then your R square will be much higher. Okay, so it will be it is indicate a better fit to the model. The trend lines can be used to model the relationship between variables, and trend lines also used extensively in modeling trend, and it actually being used for not only for regressions but most of other models that requires trend lines. Okay. So this is an example. Okay, so the price sales data. Okay, and then how we can actually see. So this is the further it is from the lines means that you might have error. So this is what we want to minimize. We want to find as much as possible the line fit to the as many dots as possible. So the more closer the dots to the line, then you have a much better fit of the predictions. And regressions analysis is a tool for building mathematical and statistical model. I think you have a good ideas of this already. And what we want to do is to build the relationship between a dependent variable or one or more independent variable. I have discussed this just now. Okay, so we have simple linear regressions, we have multiple regressions, and if you want to talk about simple linear regressions, this is the linear regressions. Okay, so this is the linear regressions. As you can see, the line is straight, so it's a lot easier for us to see the trend. But we also have nonlinear regressions. And there are times that you cannot predict regressions because there's no relation, so you won't be able to see the trend lines as what you have here. Okay. Okay, so let's have a look on the example of home market value data. Okay, so for example, here I have the data of the house age. Okay, so this is the age of the house. This is the square feet, the size of the how big the land is, and this is the market value. Oops, where's my? And this is the market value. Okay, so in this case, we can actually see, we can actually regress that. Okay, usually the machine will start with plotting the values. So when you have plot the values, you can see here, you can sort of have a feel of where the trend line would fall. Okay, so because in here we're going to have a look how the 42 homes that we have in the data sets, when we plot, what are the trends that might actually emerge from this data. So in here, if you have a look, there are two possibilities. Okay, it could be the A or it could be B. Based on the analysis, you can actually test with a number of techniques. It is possible you might actually be given two potential trend lines. So there are potential trend lines of A and B. Okay. As you can see in here, the line A, which is this one, which is this. Okay, it actually gives a much better feel that this would actually a better fit to the data. Okay, so why do you think it has a better fit to the data? Why A, not B? how do we know that certain line has a better fit to the data?
Because the dots are more near to the lines.
Very good. Okay, very good. So how do you know that the line has a better fit? It's just by looking at as simple as how many dots, how many instances, we call it, how many instances is closer to the trend lines. So in this case, B has a few instances that actually falls exactly on the line, but the problem is there's a lot more which is further away from the lines. Whereas if you have a look on A, you may not have as many that actually falls exactly on the line, but you have a few dots that is surrounding the line. So in this case, you have a few instances that actually move towards the trend line. So in this case, this is a best fit. Line A is the best fit. Okay, any questions on that? Okay, so please make sure you understand this because during the quiz or final assessment, you might be asked to justify certain things.
Madam,
Yes, Misa.
what if the instances are equally the same on both lines?
Very good. Okay, so if by eyes, if from eyes you can see that I think it's about the same. It falls about the same. Then we can have a look later on this one. Okay, so your questions is very timely. So if you have a look from the eyes, if it's actually give you the impressions that it actually about the same numbers of instances surrounding the two lines, then you can have a look on the formulas generated. Okay, so if you found that, if you found here that the y variable can provide a much better, clearer. Usually in here, you can actually have look the variables that you predicted and the R square. So you can refer to the R square. The higher the R square, although by eyes it might look similar, but any of the line that give you a higher R square, that means it's a better fit. Okay, so because sometimes our eye play illusions, right? Sometimes our eyes play tricks on us. So it might seem similar, but actually from the calculations perspective, the R square really measured the distance from the trend lines to the actual instances. So the higher the R square, you have a better confidence to say that the line with higher R square is the line with a better fit. Okay, does it answer your questions?
Yes, madam. Thank you, madam.
Great. Okay, thank you. Okay, so say we come up with the formula. So we already have this. Okay, so we have these formulas. So what does it mean? Can we actually use these formulas? Absolutely. Once you already got the formulas, this formula is absolutely usable by you right away. So once you have this, okay, so once you have, I'm not sure why, let me see whether I can do this. Okay. All right, so sorry if I have to look at the other screen here because I don't know why my drawing pad doesn't move to the other side. Okay, so once you already have this, it means that you have square feet out of two variables that you have just now. Okay, so out of two variables, just now we have age and square feet, right? We have two variables, age and square feet. But when it comes to market values, apparently the age doesn't in here because we don't have age here in the result means that out of two variables that we have, only one variable that really contribute to the price of the house, which in this case is square feet. So what about the age of the house? It probably has some contributions, but it is not significant enough. It is not strong enough for us to actually predict the market values. So please don't worry if you have 10 variables suddenly in the formulas you end up with only 3 or 4. Some variables were not actually included in here. There's nothing wrong with it could be okay, so I think the first thing that you have to do if you have 10 variables and only only say 6 that actually pops up in this variable in this formula. First thing that you have to check, make sure that all those variables is the right data sets. I mean, the right format. Okay, so sometimes if it's not in the right format, obviously it will not be able to be included. But if everything has been checked, if the data quality is sufficient, is makes sense, but those 4 variables still not included, there's nothing wrong with your data. It is simply because those 4 variables the influence may not be strong enough for regressions to capture its influence. So please don't panic. Okay, so if you have some variables which are not included into the formulas, there's nothing wrong with that. You can simply say that out of that 10 variables, 6 variables were actually selected by regression techniques. Six variables were deemed to have a strong influence on the y variable, which in this case our y variable is market value, right? So I think you have to start think like that. You have to start avoiding how to justify this. Okay, so one of the way is try to understand the concept. If you have variables, not all variables will influence the predictions in the same way. Okay, so in this case, we are actually predicting the market value. So not all variables influence the market values in the same way. In this case, we only have square feet out of 2 variables that we used just now. Okay, so in this case, how do we make use this? Okay, so if you have a house, for example, the size of the land is 2,200, around 2,200 square feet. So you can simply put the price, you can simply put the size in. So in here, you will have to multiply 35.036 multiply by 2,200 plus this. Okay, so this is the values that we mentioned just now. Okay, so this is actually, let me cut back a bit, sorry. Okay, so this is actually this. Okay, so okay, so this is actually this. This is the constant variable to make sure that the price is close enough to the actual price expected in the market. Okay, so in this case, this is the square feet, and this is the values, the absolute values that are actually used to elevate the price closer to the real price. So in this case, we know that the price of the house, the market values is around $109,752. Okay, so in this case, this is how we actually make use the result out of regressions. Okay, so and also make sure you are familiar with residuals. Later on in Wika, you would get a lot of residuals. Residuals is actually the distance, okay, the distance between the actual values to the predicted variable, the actual values to the predicted values. So in this case, the more residuals means the more errors you're actually making. Okay. So this is how we can actually make use regressions in Excel. I will show you in a few minutes. And then this is the example of result. Okay, so make sure if you have many variables, you put that in so you can see the kind of results you can, the kind of contributions each and every variables has on the residual, on the regressions. Okay. And this is residuals in Excel. Okay, so this is residual in Excel. In Wika, it's a lot more interesting. I think even in Excel, you can have this. So in Wika, you can actually have a look on errors. Okay. Okay, so this one. So the actual price is 9,000. It is predicted as 96,150 something. The errors is 6,000. Okay, so in this case, we actually put the price higher than what is supposed to be. But what worse is if you actually, this is the price and Wika predicted less. So in this case, you might actually put the price much lower than the actual market price. Okay, so in this case, you have to be careful. You have to look at what are the common residuals between, what are the common errors between the price. So you can be more careful and you can set the market price better. Okay, all right. So any questions before I proceed with demo? Oops. Any questions? Everyone still here?
Yes, madam.
Any questions before I proceed?
No questions. Clear, madam.
Okay. All right, so let me share with you one data sets. Okay, so everyone can follow how I run these regressions. Okay. Okay. All right, so in the chat, I have shared with you the data sets. Are you able to open it? Are you able to open the data sets?
Yes, madam.
Okay. All right, so this is the data sets that you have, right? So in these data sets, we only have a few rows. I actually intentionally only pick a few, so it's faster. If you have a look here, we have a couple of variables. Okay, so this is the independent variable. So we have age, gender, BMI, children, smoker, region, and charges. So in this case, most of regression technique, they don't allow most of the software that we're actually dealing with. I think Wicca also doesn't allow text. Okay, so in this case, you will have to work with only numerical data set. So what happens if we have this? What happens if we have data set, if we have column that is in the form of text? So in this case, you have to transform the data first. Okay, so keep in mind, if you have a data set that is not in numeric for regressions, you have to transform the data first. As simple as maybe you would want to do this. Numeric. Okay, so this is usually what I do for transforming the data. So what I would do, okay, so please pay attention carefully. I don't actually record this, just realize I don't record this. So please pay attention carefully. Okay, if you are dealing with kind of data set, and if you would want to transform this, okay, so I would suggest you have a look on the data first, okay, go with filter and see what kind of data you have. So in this case, you have actually two values, yes or no. So it's easier for us to actually transform. So in this case, since that I have two values, you decide what would be number one and what would be number two. So I'm going to transform this for the logical values. If this one is yes, I would be giving 1. Otherwise, I would be giving 0. So no is 0, yes is 1. Okay, so now we have this. And then to make sure that all values, all formulas actually copied to the last cell. You just put this, you point into the cell, end of the cells, and then double click. Okay, so this will copy all the cells to the last row. So you have all the yes becomes 1, all the no's becomes 0. Okay, so that's how you transform. So in this case, we can actually ignore this later on. And then we also have female and male, the same thing. I would probably, I would prefer to transform this. Okay, the same thing. You use the logical operators. If this one is equal to female, I would probably put as 2 and male as 1. So you know that 1 is male, 2 is female. And then we copy it to the last cell. Okay, so as you can see, transforming doesn't take you a lot of time if you know how to do it. Okay, so now because I don't want to use this data set, I don't want to use the original data sets to as my regression. So I will copy all. Okay, Control all, Control Z, and I will open a new worksheets. Okay, Control V. Okay, oops. Control C, and then open the worksheets and then copy here. But don't copy the formulas. You only want to copy the values. So paste and paste values only. Don't copy the formulas. The moment you copy the formulas, you might actually end up with wrong regressions later on. Just realized I didn't copy this properly. 1 sec. Okay. Is value. Okay. Okay, so just make sure there's no formulas here. For regressions, I would suggest you remove any variables that you are not going to include in your regression analysis. So I will remove this. Okay, so I'm going to remove the values that will not be useful. I will remove gender because I already transformed. And I will remove the region for now because I didn't actually decode this for the quiz later on. If you were asked to actually use these variables, then of course you have to do the transformations as what I did just now. Okay, but for these particular examples, I'm not going to include them. So for this example, as you can see, all numeric, so it will be easier for us to run the regressions now. So what we need to do with the regressions, first we're going to pull out the techniques first. So data analysis. I'm not sure, can you see it on the top? So you go to data, on the data tab, you have data analysis. Do you have this?
Yes, madam.
Okay, good. Okay, so inside data analysis, you have a lot of techniques. One of them is regressions. So if you click on regressions, okay, if you click on regressions, click OK. And this is where we're going to do the regressions as what we did just now. So input Y, what is the Y variable? Is it dependent or independent variable? What is Y variable? Is it,
Dependent.
sorry?
Dependent.
Dependent, very good. So Y is our dependent variable. So we're going to pick this range as our independent, as our dependent variable. Okay, so this is our dependent variable. So we've got that. And we're going to put X. X is independent variable, right? So we're going to put the X variable here. So this is our X variable range. Okay, so remember, this is our predictions, our dependent. This is our independent variable. Okay, so we have labels. Keep in mind, if you don't have labels, then don't tick this. But because the first line just now, we have labels. We have the row name. So put labels. We have, do you want to have specific confidence level? 95% means that you allow 5% for error. I think that is the most common one. And then where do you want to put the results? Do you want to put in the new worksheets or do you want to put here? I usually will go with this one, the default one. And if you would want to have a look on residuals, I would suggest that you have put this tick everything, so you know all information that you need to have, you have there. Okay, so this is the common settings. Okay, so labels, confidence level, which is around 95. You can put it lower, you can put it higher depending on the instructions or the policy from the company. Residuals is most common. I would suggest you take that. Standard residuals is optional, but better to have it rather than not having it when you need it. Okay, so and this would be the settings. Once everything okay, click OK. Any questions before I click OK? No? Okay. All right. So if not, then okay. So this is what I would suggest that you start getting yourself familiar with when it comes to the result. Okay, so you can have a look on the residuals later on. It's very interesting. I'm the kind of person who loves pattern, so usually I will examine this one first before I look at the numbers. But I know different people have different preference, so I think let me just proceed with this one first now. Okay, so let's have a look here. So here the R square is 0.85, which is 85%. What is the highest number? What is the perfect fit?
It's 1.
Sorry?
Is it 1?
Yeah, good. Okay, so perfect fit is 1. Okay. So now it's closer to 1, right? Who answered just now? Munir, is it? Joseph?
It's me.
Sorry, I cannot see your...
It's me, madam.
I don't see where's the...
Oh, it's Yusuf.
Okay. All right. Okay. So yes, Yusuf, it's closer to the perfect fit is 1, so it's closer to 1, means that it is quite good. It's 85% in terms of the model fitness, so it is good. The model is quite good, and the standard error here is around 5,500. So in this case, I think we have to be careful with the charge from the insurance is around. It could be the standard error is around 5,000, so it could be cheaper or more expensive with surroundings around 5,000 ringgit if the price is in ringgit. But I think what would be...
Sorry, madam, we cannot see the screen.
Oh, you cannot see the...
Yeah. I don't know why.
How about now? Can you see it?
No, no.
How about now? Is it okay?
Yes, ma'am.
Okay, good. All right, thank you. So just now, if someone asks how many instances you have in your predictions, you can answer here. You have 49 instances. You have 49 samples. Okay, that's observations is the number of samples you have. R square is the one that we want to see just now. The fitness of the model. The fitness of the model is 0.85. If you have a look in terms of percentage is around 85%, right? So it's 85%, which is good. The perfect is 100%, of course. Standard errors is around 5,500. So you have to be careful around that number. Okay, so this is the typical errors between the predicted to the actual variables. And then now let's have a look on the variables. If you put the model properly just now, you would be able to see some of your variable listed here. So you will not be able to do one by one. You should see the whole package. Okay, so last time I think most of the mistakes that people losing mark in final assessment is because They do regressions, but they do it for each and every variable. So they do age first, and then gender first, and then gender next, and then BMI next. So that is wrong. Okay, regressions, you want to see the full sets of, you want to see the whole sets of independent variables. You don't do one by one. So you just now we have just now we have 1, 2, 3, 4, 5, 6. Sorry. Okay, just now we have 1, 2, 3, 4, 5. We have 5 independent variable. We have we have also 5 independent variable here, which means that all the independent variable were deemed as contributing, have a relationship with the price of the insurance. But not all variables have the same coefficients. So what do we have to pay attention next is whichever coefficients higher or highest, that means it has the most contributions. If you have a look here, the one that actually contributed the most to in terms of coefficient is smoker. Okay, so in this case, the price of your insurance, the moment they actually identify that you are a smoker, it will be the alert that you will have to pay more in terms of health insurance, in terms of the insurance charges. Okay, so the variable that contribute the most to the higher price of the insurance is smoker status. And then the next one, if you have a look here, is gender. Just now we have 1 and 2, right? 1 is what?
I
It's
think male.
male.
1 is male, 2
And
is
2 is
female, right? Yeah, good. So 1 is male, 2 is female. What is interesting from here, if you have a look, it has negative coefficient, which means what the negative coefficient means. Anybody wants to try? Come on. It's okay to make mistakes. We'll learn together. What the negative coefficient means. Any sister?
No correlation.
It has correlation, Aisha. It has correlations, but it actually
Negative.
influence in different way. So if you have this, what do you think the result would be? Who would
To
pay higher?
reduce,
Yeah?
if it's minus, it reduce the
Yeah. So who will pay higher? Is it male or female?
male.
Sorry?
Male.
Okay, good. Yeah. Okay. Thank you, Yusuf. So Aisha, just now it has correlation, Aisha, but because of it has negative coefficient, and just now we have actually put higher numbers on female, right? 1 is male, 2 is female. So in this case, the higher the values will reduce the price of the insurance. So because of the 2 is female, so female, because we have negative coefficient here, so female actually pay cheaper insurance as compared to male. I have no idea why. Okay, so don't ask me whether it is. I don't build these data sets, but this is what the data sets tell. In here, apparently, the female insurance is actually cheaper as compared to male. Okay, and another coefficient here is children. What does it mean? This is all positive coefficient, right? So you have children, you will pay more insurance. You have a higher BMI, you pay more insurance. You are older, you are paying more insurance. But what is interesting here, out of this coefficient is about the same, but the highest coefficient is smoker and gender. So it seems out of 5 variables, not all give the same strength to the price. It has different way to influence the price. Some actually makes it higher, some actually makes it lower. But you really need to know how to read how this variable influence the Y variable, influence the predictions. Okay, so I would really suggest make yourself familiar with how you read the coefficients in regressions. Okay, so that would be one of the way you can actually learn how to read this. And this is the residual if you want to have a look. Okay, so some people actually charge, the predicted charge is around 3,000, but actually it is higher. The actual residual is actually higher, so they're actually paying more than what they're supposed to pay. Okay, so and you can, from here you can see the trend, what are the most common, whether it will be overcharge or lower charge as compared to what the model predicts. Okay. Okay, so I think that'll be all. Any questions before I conclude the sessions? Any questions on this? How you read the coefficient? Is it clear?
Yes, madam.
Okay. How about others? Is it clear? Please don't
Yes,
hesitate.
madam.
Yeah. Okay, good. Thank you. Any other? Please don't hesitate. If you're not sure, let me know. Well, we are still here. Shall I call names? Okay. Abdul Rahman, is it clear?
Yes, madam.
Okay, good. So is it clear you know how to read these coefficients?
Yeah, based on your last explanation, I understood how to read the code.
Okay, very good. Okay, thank you, Abdul Rahman. Shafiq, is it clear?
Clear, madam.
Okay, good. Sarah?
Yes, madam.
So in this case, what the negative coefficient means, Sarah? Sarah? Can you hear me?
Sorry, madam. Can you repeat the question?
So what does the negative coefficient means in this case? Nisa, can you help? Or Aisha, could you help Sarah what the negative coefficient means?
The value is reduced, like between the two genders, one of it has a lower value.
Okay, so which one that will pay higher? Is it the values, is it the one that is assigned with 1 or the one that actually assigned with 2?
One.
Okay, so the values with 1 will actually pay higher, right? Because okay, so I'm not sure whether you can hear me properly. Okay, later on, I would suggest you have a look on this one. Okay, so if you're still not sure, how can this be actually influenced? So you pull out this, gender numeric line fit, okay, and see which one actually pay higher, the female or the male. Okay, so as you can see in here, it's actually the male paying more. Okay, the charges. Okay, so that's you can see why it is male. Okay, and you can have a look the gender numeric residual. Pull out, see, have a look. What are the most common prices that people actually pay?
Sorry, madam. Sorry. Can I answer now?
Sure, yes.
So while the independent variable tends to increase, dependent one tends to decrease. So in this case, for instance, if the number of children is higher, then the paying insurance will be more.
Very good.
so as the age of the person. If it is higher, then the insurance will be more.
Very good. Okay. If you are very good, Sarah. So if later on you are not sure, okay, you are not sure, pull out the BMI fit plot and have a look what is the trend here. Okay. So in this case, we can see, okay, so people who actually have a higher BMI, they would actually pay more, right? So that the trend shows that's how it is. So then you will have a much better say what is the trend. Very good, Sarah. Okay. Okay, so thank you, Aisha, and everyone. I think that sort of conclude what we're going to learn, what we have learned today. And yeah, let me know if you're still not sure. Let me know on how I can assist, but make sure you revise against the notes, and then I will share with you the data sets here. I'm very sure all of you have downloaded, but let me share this one as well as the actual data sets on iTalim, so you can revise what we have done in the class. Okay. Okay, so I think that will be all for today. If my health getting better, I'll try to see you on Thursday. Otherwise, as usual, I'll give you some activities or I'll record some notes, some lecture notes, some lectures for you to get into the next topic, inshallah. Okay, so take care, everyone. Please stay safe, please stay safe and stay healthy. I learned my lesson. I didn't take care of my health, and I got infected. So hopefully you don't have to experience what I experienced. So please stay safe and healthy, and take care of yourself. All right. Let me know if I can be of any help. Okay. So take care, everyone. Assalamualaikum.
Take care, madam. Thank you. Assalamualaikum.
Thank you, madam.
Waalaikumsalam, madam.
Thank
you, madam.
See you soon, madam.
Pleasure. Take care.
Thank you, madam.
Thank
You
you.
too, madam.